And this is why my first move is to change the little r to big R. And then we're supposed to find the centroid, I guess, of this region using proper technology, right? I don't think I have talked about the centroid of a curve in here. I have not yet talked about the centroid of an area. That's different. Right?
I think we may touched on it last.
Oh, we did?
You find the centroid of both points, basically?
Yeah.
Of both sides?
Yeah. Right.
Centroid and y centroid.
Yeah. I mean, something like that. I mean, what you can think of it this. I mean, the way to derive the stupid formula, and I guess I don't need to here to do this problem, but if you take this thing and you like chop it into little vertical bars like so, right? Then the width of this bar would be dx. All right, and the of course the height would be, say, y. So this would have like the center of mass for this would just be here in the middle. And so how to say this? It's essentially that you have, and I'm sorry, I have to, if I don't think about it in terms of actual mass density, I'll get into trouble. So it's as if you got a little dm at, you know, x comma y over 2, and the dm is equal to, let's say, sigma dA. This is the mass, sigma is the dm dA, it's the mass per unit area. The area of that is y dx, yeah. And then, so then to find the x bar, you have 1 over the total mass, the integral of like x dm. But what that is 1 over m, the integral of x times, well, the dm again was sigma y dx. And I seem to have lost my, yeah, this is going to be fine for the x, I think. So you have to integrate, do this integral. To find centroid, you just put this thing equal to 1. The density is equal to 1. So I think the formula for x bar is just like 1 over the total area. This becomes area. So you have 1 over the area integral of xy dx, is that right? For x bar. And then the y bar is 1 over m, the integral of y dm. And that is, when you put, that's 1 over m. The y is at y over 2. It's actually not y, I had to put y over 2 here because that's where the little bar is at, I should say. And so the dm is still sigma y dx. And so you get, 1 over the area integral of y squared over 2, I think, dx. That gives you the y bar. The coordinate, is this right? Yay. And now, these are great, but inappropriate for this problem because this problem is in terms of what? Of this is more natural to state in terms of polar coordinates, right? So thankfully, he has the decency to tell us the formulas for polar coordinates in the problem before. I will not, it would probably eat 10 minutes of my time to derive those. Let me just state them and use them. I think that's what you want me to do. So x bar, yes, x bar is 1 over 3a as it happens, veered integral from alpha to beta. And I'll just write r cubed cosine theta d theta Although I will admit, it is very tempting. I would like to derive these 1 over 3a, but I shouldn't behave. Integral from alpha to beta of r cubed. By the way, this is not something I expect you to memorize. The stuff I had up on the board here earlier, I think you should know. You should have that memorized. How to find a centroid of a curve, that's not an unreasonable question. This stuff to me is not something I would advocate you memorizing, because it is really, this is some sort of combination of introductory physics thinking and the infinitesimal method. It's just too far removed from what's central to this course. I can't, in good conscience, make you memorize these. So I don't. I mean, there's homework on it, right? And if you were to do it on the test, I would give you the formula for the centroid of an area. I'm not saying that I wouldn't ask you to calculate them. I'm just saying I would help you out in terms of remembering the formula. Okay, so anyway, long story short, what's alpha and beta? Here.
Semantics, but I think we should be d theta the sine theta.
Oh, yes. Otherwise, we have to take away my points. Now, by symmetry, if I calculate one, I've calculated the other. Right? Because there's no difference between x and y for this shape. Right?
Yeah.
So let's just pick on, I'll pick on x, why not? What's the area? I don't think I need to do calculus to figure that out.
Well, that's the thing I think they wanted you to do.
I mean, fine, we can calculate the area if we want me to, but it's not that exciting. So area is integral from 0 to pi over 2 of 1/2 r squared dr d theta. Excuse me, r squared d theta. So that's pi r squared over 4. I mean, it's outer radius r equals to r, inner radius 0, so that's the area. And so if I flip that over, I get, what do I get? 4 divided by 3 pi r squared, right? Integral from 0 to pi over 2. And then, let's see here, r, what is r equal to? R is equal to r, right? He has rho in the 10.4.3 formula, right?
Right.
But r is a function of, rho is a function of theta. I've just said, I'm just saying r of theta is equal to rho of theta, okay? When I use r here, I'm talking about, I'm using it as a variable. The curve, which is the outer,
You mean capital R?
it happens to be equal to capital R because it's this purple curve right here, right? So that is just r cubed cosine theta d theta, which is, 4 r over 3 pi. I mean, integral of cosine theta d theta is what? Sine of pi over 2 is 1. Sine of 0 is 0, right? Fine, I'll write it down. You guys make me work so hard. Monsters. And then the r cubed and the r squared reduces, so 4r over 3 pi. Yay. Have any of you worked it out? Oh, well, most of you will tell me you didn't cover section 6.4 in Calculus 1. There's always a snow day or some excuse not to cover this section. I mean, I wouldn't cover this section in Calculus 1 sometimes, but anyway, trust me, if you do this in Cartesian formulas, in the Cartesian world, it is not as nice. Because in the Cartesian world, y is equal to the square root of r squared minus x squared. And the integrals I have written here but erased are not as pretty. This is much easier, as it should be. This is something that's in the world of polar coordinates. It's a quarter circle. Polar coordinates are the natural tool here. Well, guys, this is kind of how it's going to go for a little bit. I hope you have more questions tomorrow. I still owe you a derivation of the parametric slope formula. I just got bored, so I didn't come back to it yet. Sorry.